Hi folks, welcome to Broadband Deployment News. Comcast has agreed to stop using the term 10G in association with their Xfinity network because it's been deemed to be misleading. Be right back with the story. Hey there, Rick Uzzi with Zcorum with Broadband Deployment News. So wanted to cover this because it's something that I just saw come out, and I would agree with this being misleading. I wasn't really paying attention to the ads, but you see here, this is in Ars Technica. Comcast reluctantly agrees to stop using its misleading 10G network claims. Comcast said it will drop Xfinity 10G network brand name after losing an appeal. And Ars Technica would be no fan of Comcast or any probably big companies, certainly big broadband companies. So you see here that they say misleading in the headline, although it was deemed to be misleading by a watchdog group. That really has no, I guess that has no power. It's kind of a self-governing kind of group, has no real power, but Comcast has agreed. They did appeal it to a little higher level at that watchdog group, and it was they agreed. So read through this real quick. Comcast has reluctantly agreed to discontinue its Xfinity 10G network brand name after losing appeal of a ruling that found the marketing term was misleading. It will keep using the term 10G in other ways, however. And you might be listening to this or watching this and going, yeah, well, 10G, that would be what, 10 gigabits per second? Well, that is not what 10G is in this case when Comcast is talking about it, because 10G is actually talking about a term that CableLabs came up with. It was like a 10G initiative before they fully finalized and kind of made the DOCSIS 4.0 standard what it is. 10G was kind of the thing that was saying, okay, here's how the cable industry is going to be responding to 5G. So it really was, I mean, they didn't necessarily connect the two that way, but it really was in response to a lot of the hype about 5G. Because when people started talking about 5G, it was like, wow, we're going to be able to get these huge speeds over a wireless network. It's going to be 5G. In that case, people were actually, and a lot of people were thinking, wow, that's 5 gigabits per second. But with 5G, it was not. It was actually meant to be fifth generation of wireless. So you had 4G, right? Everybody's familiar with their 4G service. And then we went to 5G, the next level up. And there was a lot of hype because a lot of people were talking about these super fast speeds. But really what they were talking about was millimeter wave wireless. And millimeter wave wireless is very fast. It's, a gig and better on the speeds. You could do that, symmetrical, I believe. But the problem was that was a very limited kind of applications because it requires small cell technology. Each cell has to have line of sight. You need line of sight to the end location, the endpoint receiver, which would be, meaning it had to be on the outside of a house. If somebody's going to get that line of sight to a small cell, or, Verizon came out with their millimeter wave. They came out with, I think, with a CP unit where half of it was on the outside of a window, the other half was on the inside of the window. But again, you still needed line of sight to a small cell, and that meant like not even a tree in the way because millimeter wave has high attenuation. So even moisture in the air can make the signal attenuate, and you could get gaps in your service. So again, small areas, urban areas where you've got lots of people concentrated, you can have lots of small cells sitting on buildings, street lights, those kinds of things. And you can get fast 5G speeds that way. But that was not going to propagate everywhere. So T-Mobile, when they launched their 5G service, they did their nationwide 5G, and that was using mid-band spectrum, which they had a good amount of, more so than the other carriers. So they started really heavily into that. Verizon was promoting the 5G millimeter wave in urban areas. AT&T was kind of sitting back. They didn't have much of either of the spectrum. AT&T recently has started getting into that more. I just reported on that the other day, where AT&T is now promoting, they're in 50 some odd markets, I think, now with their 5G mid-band spectrum, because Verizon and AT&T acquired C-band spectrum, which is mid-band spectrum. T-Mobile had mid-band spectrum already, plus they had, I think, acquired some other, and then there's CBRS spectrum that some fixed wireless providers are using for mid-band spectrum as well. So 5G, fifth generation. 10G was not the 10th generation of DOCSIS or cable. It was supposed to be 10 gigabits per second. So when someone hears the term 10G and they hear 10 gigabits per second, that really is what 10G was supposed to be. But, that's not a reality yet and may not be anytime in the near future. And originally when CableLabs was talking about this, I think they were talking about 10G symmetrical service. And I don't think anybody thinks that's going to be a reality at all. So I think the top speeds people are talking about maybe symmetrical would be 6 gig by 6 gig and maybe 10 gig on the downstream, maybe 6 gig up if you're going to be doing 10G service. And by the way, I did a video about this 4 years ago, it looks like, I believe, 4 years ago on 10G when 2020, when it was first kind of being announced, and about the same time 5G had been announced, and they were fighting, there was kind of back and forth 5G, 10G. So I talked about 10G. I talked about 5G actually in a series that this was connected with. I did one on 5G as well. But if you want to know what 10G is and what DOCSIS 4.0 is kind of, and how they, how that initiative is going to get the higher speeds, this is a really good video if you want to check that out. So I've got a link to that in the description, as well as a link to this article that we're looking at here. So check that out. So you see Verizon and T-Mobile both challenged Comcast's advertising of 10G, a term used by cable companies since it was unveiled in January 2019 by industry lobby group NCTA, the Internet and Television Association. I don't think that's true. I think CableLabs introduced the term. I think NCTA popularized it because they are an association of cable operators. But CableLabs are the people that developed the standards, the DOCSIS standards. So CableLabs, I believe, introduced it again as a way to counter the 5G thing. And it was supposed to be kind of talking about this initiative that was going to bring additional speeds. And then DOCSIS 4 was officially released, and that encompassed a lot of these things that were in 10G, probably really most of them. So again, I think that was CableLabs and not the NCTA. They mentioned, we wrote in 2019 that the cable industry's 10G marketing was likely to confuse customers or consumers and seemed to be a way of countering 5G hype generated by wireless companies. I was saying the same thing at the time. 10G doesn't refer to the 10th generation of technology. It's a reference to 10 gigabits per second broadband connections, which would be much faster than the actual speeds on standard cable networks today. The challenges lodged against Comcast marketing were filed with the advertising industry's self-regulatory system run by the BBB, Better Business Bureau National Programs, BBB's National Advertising Division, or NAD. They ruled against Comcast in October, but Comcast appealed to the National Advertising Review Board, NARB. The NARB announced its ruling today, and that was a couple days ago, agreeing with NAD. NARB agreed with NAD that Comcast should discontinue use of the term 10G, both when used in the name of the service itself, for example, Xfinity 10G network, as well as when used to describe the Xfinity network. The use of 10G in a manner that is not false or misleading and is consistent with the panel decision is not precluded by the panel recommendations. So they can still use 10G because it is a real thing. They just don't want to make it sound like their network is 10 gigabits per second because it's not. At least, and again, 10G is not talking about any fiber that Comcast may deploy. It's talking about when the people, in the sense that they were using it, when people are talking about it in that sense, it's really talking about DOCSIS 4.0 kinds of technologies that can get closer to 10 gigabits per second, but not 10 gigabits per second, maybe on the downstream at some point. Says Comcast will discontinue the brand name. Comcast agreed to make the change in an advertiser statement that it provided to NARB. Although Comcast strongly disagrees with NARB's analysis and approach, Comcast will discontinue use of the brand name Xfinity 10G network and will not use the term 10G in a manner that misleadingly describes the Xfinity network itself, Comcast said. And it is very misleading. Why would you use, no consumer knows what 10G is from the standpoint of, like I mentioned in that video that I did 4 years ago, what all of that stuff is. All they know is, wow, 10G, 10 gigabits per second. It's Comcast, Xfinity, they got 10 gigabits per second. Well, they don't, unless you pay a bunch of money for a full fiber to the premise service that they may offer in some markets. Comcast said it disagrees with the recommendation to discontinue the brand name because the company makes available 10 gigabits per second of internet speeds to 98% of its subscribers upon request. Yes, if you order a fiber connection, not a 10G cable connection. But those 10G speeds aren't available in Comcast typical service plans and require a fiber to the home connection instead of a standard cable installation. The Comcast Gigabit Pro fiber connection that provides 10 gig speeds costs $300 a month, plus a $20 modem lease fee. It also requires a $500 install charge and a $500 activation charge. So, in that sense, Comcast saying that they offer 10G service in a market, they can do that because they do. Just like Google can say they offer 10 gigs, I think they do, or maybe even in some markets they're saying 25 gigs. Chattanooga, they're saying they can offer 25 gigs, and they can, but they can't say it's kind of misleading to say you've got a 25G network or a 10G network, because that makes people think that everybody could get that. And especially in the case of Comcast, when they're really leveraging the 10G from the CableLabs 10G initiative and DOCSIS 4.0. They were really talking about DOCSIS 4.0 and not their 10 gig fiber service. When contacted by ARS, a Comcast person said, "We disagree with the decision, but are pleased that we have confirmed our continued use of 10G in advertising." And again, they can advertise all they want that they have 10 gig service available in markets. The NARB said that the recent availability of 10 gig speeds through the Gigabit Pro service tiers does not support the superior speed claim for a 10 gig or a 10 gigabit per second claim for the Xfinity network as a whole. As the NARB noted, there is an absence of data showing how many Comcast customers actually use that service, and not many, maybe businesses, maybe some businesses, but not many, if any, residential customers are going to purchase a, $300 a month 10 gig connection. I mean, they'd be more than happy with a gig. NARB also said that 10G is misleading because of the implied comparison to 5G wireless networks, and that, again, was kind of the reasoning behind CableLabs branding the 10G thing. The NARB panel concluded that 10G expressly communicates at a minimum that users of Xfinity network will experience significantly faster speeds than are available on 5G networks. The announcement of the ruling said this express claim is not supported because the record does not contain any data comparing speeds experienced by Xfinity network users with speeds experienced by subscribers to 5G networks. And again, it depends on the type of 5G you're getting. If you're getting the millimeter wave 5G, you're getting faster than you could probably get on a lot of Comcast accounts. On the upspeed, for example, Comcast, that they're offering high downloads, but there's still a little bit limit on the uploads. That's going to be changing as they get more, as they go to DOCSIS full duplex. But what they're saying here is when you hear 10G network, people kind of compare it in their minds to 5G network, like a fifth generation wireless network or mobile network versus gigabits per second. So people are kind of making that mental comparison in their mind as well, thinking, oh, well, this 10G's got to be better than this 5G. As NAD has previously stated, 10G is more of an aspirational term rather than something that's offered over today's cable networks. Over the past 5 years, the NCTA has been using the term 10G to describe just about any improvement to cable networks, regardless of the actual speeds. And that's true because 10G and DOCSIS 4.0 really in general was a lot of different things that would come together to improve the speeds of cable modem service. And those were things that were done prior to DOCSIS 4.0. For example, distributed access architecture, where you take a small CMTS and put it, out to the edge. So you have things called remote PHY and remote MAC-PHY. And that's distributed access architecture. So remote MAC-PHY is where you take basically what's a small CMTS. Normally you'd have a big CMTS back in the head end, and you'd be serving everybody from there. But instead, you take a small CMTS that can handle fewer customers, and you run digital fiber out as close to the customers as you can, like a neighborhood or something like that. And then you've got digital fiber instead of analog fiber. So that's benefit number one. Plus, you've got the service closer to the customer, so that can increase the speeds. You've got remote PHY, where you're actually taking the physical portions, like the physical coax connections. They're going out in the field with a remote an RPD, a remote PHY device, and that helps improve as well. Because again, the same difference whether you're doing the remote MAC-PHY or the remote PHY, you're running digital fiber as opposed to analog fiber. further out to the customer. So that right there can make a big difference. And there's the other things like full duplex that Comcast is looking at. You've got extended spectrum DOCSIS. A lot of this is explained, by the way, in that video, if you want to check it out. Extended spectrum DOCSIS, where the cable operators are increasing the amount of spectrum that they have, where they're going up to 1.8 gigahertz, I think it is, on their networks, so they can have more downstream speed, but especially on the upstream speed, they can increase the amount that they can offer on the upstream, since that's a real liability with cable operators. They've generally, because of growing up in this RF world where they had to kind of split what they were going to do downstream and upstream on the same spectrum. As one would make sense, it would make sense that you would have more downstream, because that's really what people were using, and that's really what people are using today. So people don't need symmetrical service today. If they got a gig down and they got a 100 meg up, they'd have plenty, most likely, for everything that they're doing if they're a normal kind of internet customer. But the cable operators are trying to be able to do that, to be able to get higher upload speeds. Instead of being limited to 10 megabits per second up, to get higher and higher on that. And again, Comcast is looking at full duplex so that they could offer a gig symmetrical over their cable plant, or maybe even up to 6 gig symmetrical on their cable plant. And certainly a lot higher in the upstream on any of the plans that they're doing. And folks like Charter and Cox, I believe, are looking at extended spectrum DOCSIS, where they are going high. That's going to allow them to offer high download speeds, very high download speeds, and much higher upload speeds than they've been able to offer doing that. It won't be symmetrical, but they'll be able to really up the upload speeds. So that's the direction that the industry is going. So again, that's true. That's what they're saying there, is that this 10G kind of described any kind of improvements that are getting these cable operators closer to being able to produce or provide these high speeds. Let's see, the NCTA coincidentally announced or issued a press release yesterday hailing the 5th anniversary of its 10G announcement. And again, it was really CableLabs. I think NCTA was promoting it. 5 years on, the future is even closer. Here in 2024, the promise of 10G is becoming more and more of a reality, the NCTA said. The announcement listed some examples of multi-gig, but not 10 gig cable speeds, some of which were only achieved in lab testing or demos. And that's important to note, because cable plants are very susceptible to RF interference. So you can put you can do cable testing in a lab where you've got short runs and not a lot of interference, and you got make sure everything's tight, all your connectors are tight, and you can get really high speeds. But as soon as you go out in the field and you're going long distances and you've got connectors that can come loose, you've got cracks and can get in the cable, and you've got water that can get in actives or passives. You've got customers who don't realize they need to tighten the back of their cable modem, the connector on their cable modem. It can really impact speeds. Whereas a fiber connection, it's light, and it's not susceptible to that. That's why the distributed access architecture is so important, because you can get a lot of that RF signal impairment out of the system by going digital fiber as close to the customer as you can get. And then that limits the amount of RF problems that you've got. So it's true that you're going to get much higher speeds in a lab than you will once you put that out in the field. And once you do put it out in the field, it's going to degrade over time, because again, you put it out there in your areas of the plant that are still coax, that are susceptible to RF issues. Things are going to happen over time. Again, you have squirrel chews, you'll have a bend in a cable that gets in there, you'll have different things that happen that are going to cause RF issues, that are going to cause the plant to degrade, and then you need to go out and fix those things. So over time, that's basically what happens. So it says here, for all of you cable broadband users, just remember to ignore 10G and cable company marketing and check the actual speeds you're paying for. So again, if you see that somebody's offering 10 gigabits per second, that means it's 10G. If they say, hey, it's 10 gigabits per second symmetrical, it could be a fiber operator. Could be Comcast coming out later and saying, hey, we offer a 10 gig by a 6 gig cable connection. You don't have to ignore that. You just have to verify that that's what they're marketing, or that's what they are saying. So, and by the way, if you're a cable operator, we are providing some tools that can really help you out, because you are competing with fiber. We have fiber customers, we have cable customers. But if you've got fiber in your backyard there and you're trying to figure out how to make the most out of your cable network, then we can help with that. And that's really important because it's much less expensive for a cable operator to upgrade to 10G, really DOCSIS 4.0, DOCSIS 3.1 or DOCSIS 4.0. Much less expensive for them to do that. Let's say put out, do the remote MAC-PHY or the remote PHY by getting the distributed access architecture out there, or doing the extended spectrum DOCSIS, those kinds of things, and then changing out the CPE at the customer as they need to. It's much less expensive to do that than to rip out that last mile architecture and go straight fiber all the way to the customer. We were talking about like a couple $100 versus a couple of $1,000 in costs for them to do that. So most of them are trying in their existing service areas where they have HFC infrastructure, they're trying to upgrade that so that they can offer higher download speeds and higher upload speeds and better compete with fiber. But it's still an HFC network. We can help you in lots of different ways. One, for example, is proactive network maintenance. That's something that you can, it's DOCSIS P&M. You can run that in your network. We've got a application called Pre-Equalization Analyzer that you can look at your network and figure out what's going to break before it actually breaks. That's why it's proactive. So you can see that that your network is compensating for some impairments, some RF impairments, and service is okay for now, but it's just like anything, it's going to get worse, and you can get out there and fix it before something breaks and a customer calls, and then you're running around, like it's a fire drill. So we've got that. We've got and also in Pre-Equalization Analyzer, there's something that will let you know which devices will support a DOCSIS 3.1 upgrade. So you can look at that if you haven't upgraded yet to DOCSIS 3.1 and OFDM and OFDMA channels. We also have something, if you're on DOCSIS 3.1 or thinking about it, that will immediately increase your capacity. It's called DOCSIS Profile Management Application, that will look at your network and determine the optimum modulation profile for your DOCSIS 3.1 modems, and then it will automatically adjust that as your plant conditions change. And that can give you like 30-40% increase in capacity as soon as you get that implemented. Because what happens sometimes is you'll get a DOCSIS 3.1 modem out there or modems out there, and they don't connect well on DOCSIS 3.1 because there's impairments in the plant, or they were connecting, but then there's some noise that pops up and suddenly they're back down, and on SC-QAM they're not connecting on DOCSIS 3.1. So you lose that capacity. And then you lose capacity on your SC-QAM channels because now you've got that DOCSIS 3.1 modem connecting on your SC-QAM. So it's called PMA. It's Profile Management Application. It's something that we can provide that will, again, it will look at your network. It analyzes the RX-MER. It determines what the best modulation profiles are for all of your DOCSIS 3.1 modems, and it sets it at those. And then it will put little, not exclusion zones, something similar, where it will avoid any noise that's in the plant. And then as conditions change, it's automatic. It will automatically analyze that again and change things so that, again, all of your DOCSIS 3.1 modems are connecting at the highest modulation profile available. And that's going to increase the speeds for your customers. It'll increase capacity in your DOCSIS 3.1 network, and it keeps the capacity on your DOCSIS 3.0 network better because, again, you're keeping your DOCSIS 3.1 modems off of your SC-QAM channels. So anyway, check us out. You'll see our website there, our email address, our phone number. So if you've got interest in any of those things, just go to our website, look for DOCSIS Proactive Network Maintenance, look for Profile Management Application or DOCSIS PMA. You'll see those things on our website. Or send us an email, give us a call. We'll be happy to tell you about it. Thanks for joining me. I appreciate it. So if this was helpful, if you give me a like on the video, I'd appreciate it. And if you have not subscribed, click the subscribe button, ring the bell, and you will be notified when I'm live. Thanks again. See you next time. Bye-bye.